This is Teledyne Imaging. A fusion of expertise means new ways for our partners, customers, and employees to see the world. Everywhere you look, we are micro and macro, minute and massive, from the deepest depths to the furthest points imaginable, from sensors to systems, microwaves to X-rays, across the spectrum. It's the things we will do together that can make anything a reality. This is Teledyne Imaging. Now, just imagine the possibilities.
My name is Dale Deering. I'm the Senior Director for Product Management for Teledyne. We make imagers and cameras and visible, infrared, all sorts of different devices. And I'm here today at the show in Mumbai, and we're looking at a demonstration of a typical application that we service with our cameras. This is an inspection application where we want to see the quality of the parts as they move across a conveyor. In this case, it's a fast-moving consumer goods application where we want to check chewing gum or erasers or connectors, different types of goods that want to be inspected. So we have actually two cameras here. We have two line scan cameras, a color camera, the Linear 2 5 gig E, and we also have a monochrome camera behind it. It's a Linear 2 Linear Light monochrome camera, and then we have the Z-Track camera here, which is actually a 3D profilometer, and it actually is used to measure three dimensions on parts. So if we look at the applications here now, this is an application we call Sherlock. And Sherlock allows us to take the image data from the camera and be able to do different things with it. In this case, with the color application, we're actually identifying the type of product we have. Maybe it's different flavors of chewing gum, and we want to sort them out on our conveyor later. Or maybe we're doing just a quality inspection of the printing. In the monochrome camera, we're using it to demonstrate how the application can actually do metrology, or actually make measurements of the part. So we can tell if the part is formed correctly, we can tell if it was manufactured correctly, and again, we can use that information and send it downstream to an ejector to maybe eject the part if it's faulty, or to use it to verify the quality. And this ensures, this kind of application ensures that all of the parts that are manufactured are 100% inspected, and we can ensure the quality of the parts that are made. The Z-Track in the application here, you can see, is actually creating a three-dimensional metrology information, and we can use that to make sure all the connectors, all the contacts on the connector are present, or they've been formed correctly, or the dimensions are correct. And again, we can sort that out downstream, make sure that we are passing the good ones and failing the poor ones. So that just gives you a quick overview of this station, what we're doing here in the Mumbai Business Show here in 2023.
Welcome to Automation Expert 2023. I'm Mumbai presenting Z-Track in a ring layout to combine multiple sensor output into one 3D model and then process that 3D model using Sherlock 8 and extract various measurement areas that customers are interested in. We have seen tremendous uptake in interest of 3D cameras and Teledyne's vision technology. This has been our first foray in automation technology, automation expo, and we are very encouraged by the response we have seen so far. Thank you. This is Z-Track 2 S2K series. We have 4 sensors configured. These are 2 blue sensors, top and bottom, and 2 red sensors left and right. And we are doing multi-sensor synchronization, and we are reconstructing a 360-degree view of the part. The part is a miniature model that looks something like this. It has various parts that need to be measured. There is a groove, there are some radius that needs to be measured, there's some pegs, there's some bolts, but these happen to be on an incline and they need to be measured accordingly. The more important part here is that we are doing the synchronization of these multiple sensors using a single data case, closely enough that these sensors, only one of them has the shaft encoder, quadrature shaft encoder input connected to it, and the rest of the sensors are synchronized all the way.
We provide different small sensors. As you see here, we have different speed sensor with phase 2K, phase 4K with very high speed. We also have the very standard CMOS sensor for industrial applications. At the same time, here, as you see, we can provide a very smaller pixels and the 2 megapixel sensor. Also, the line sensor as well for different applications. In the meantime, we also have the X-ray dental sensor as well. As you see, we provide a total complete solutions. The user just need to try to develop the software by themselves. And we provide the SDK for customer. You can use own software to fit a different application as well. So we provide total complete solution for different market, and user can pick up which solution you want. Here's our product portfolio. Also, we provide the module solutions. As you see, we provide the optimum 2 megapixels, which is dedicated for the barcode applications. Also, we can use it for the autofocus function. We could maybe for the multi-focus. This platform is quite simple. You just need to connect the MIPI interface into JSON nano platforms. We also provide the standard drivers for users. When you gather the modules, you just need to develop the soft development. So as you can see in the monitor, we are changing the focus distance. We can gather the different distance images. It's quite good for barcode applications. Yeah. The next one, this the video is for the standard CMOS sensors and the modules. You can see we provided the global shutter sensor, even the running the faster fan speed, we still can get a very good image. Here's our total solution in the market today. So you can contact us if you have any solution for the machinations. We can provide anything and the solution can fulfill your requirement. And their location.
Is the Axis camera. This is a contact image sensor. The sensor is located right here, and this particularity has a illumination and sensor integrated into one module. It's meant to be operated very close to the actual target, between 1 and 1.5 centimeter. This sensor itself is 14K pixels wide and can produce up to 128 kilohertz at 40 micron, which relates to approximately 5 meters per second scanning of the actual surface. What we have here is a simulation of a battery inspection. It consists of an aluminum film with a layer coating that's on top of it, which could be either carbon or graphite material mixed with lithium, which is very typical. This would be consistent with the anode inspection of the actual battery. The software itself is based on Sepera SDK, and we make the use of a GPU to accelerate the processing and minimize CPU usage. What you have here is you have the red lines indicating the detection of the edge of the inspection done by the actual GPU in the system, and the black area is being inspected by comparing it locally with the region above and below it to detect any anomalies in the actual surface. The anomalies themselves are then extracted by the host PC, and we create an ROI provided by the GPU for further processing. On the right here, we have a quick video talking about the various components. This is the contact image sensor, and this is the complete imaging system. It's connected through an optical link to the actual frame grabber, and the processing is actually occurring inside a PC itself.